All right, so the warm-up that you had was the airplane. It's on a string that's 5 meters long. The velocity of the plane is 34 meters per second. What kind of velocity is that anyways?
Tangential velocity.
Yeah, it's tangential velocity. Tangential velocity. And then I asked you for t, and what's t in this case? It's the period, right? It's the length of time it takes to go around one time. Now, so in order to do this problem, you're going to use the tangential velocity definition, which says that tangential velocity is 2 pi r, or the circumference of the circle, divided by the period. But in this case, we want to solve for what? Period, t. So we got to take the t, and we got to move it to the other side. Right. So we're going to have t is equal to 2 pi r over the tangential velocity. The t and the v just switch places. Anytime you move from one side of the equation, you just move to the other side of the equation, then you flip up to the top or down to the bottom, whatever the case may be. So plug our numbers in. So you get 2 pi. R is 5 meters. Velocity is 34 meters per second. So what does the calculator tell you it is? 0.92? So 0.92. And what's the unit? Seconds. Because remember, you're talking about a time.
2 NGs.
Questions so far? Okay, so now, hopefully you picked up a copy of the worksheet. And there should be 10 questions on this thing. Now, there's been a couple of questions, but that's not the one I want you to have. There were a couple of questions over that worksheet, and I want to go over it with you because I don't want you to get stuck on something silly. All right. So at the bottom there, we see there's a question that says that Professor Brown holds on to the end of the minute hand of a clock. But it doesn't seem to provide us with a whole lot of work or a whole lot of information. I'm never good at these things. All right. Because it just basically says it's, 4 meters long. And then it asks us for what's the centripetal acceleration. And you really, so far, you've got about 2 equations. You've got centripetal acceleration is equal to the tangential velocity squared divided by radius. But you definitely don't have the tangential velocity. And then we had another one from yesterday, and it's also on the top of the page, but it's kind of hidden, that says 4 pi squared r over t squared. And this is a better possibility because we do have r. What's r in this case? It's 4 meters. It's the length of the hand. But they didn't give us period. But they did, really. Because what do you know? He's hanging on the end of the minute hand, right? He's on the big hand of the clock. And how long does it take him to get around the clock if he's hanging on the minute hand?
An hour.
Takes him 1 hour or 60 minutes. Right? So how many seconds, because we need period in seconds, how many seconds is in an hour? 3,600. 3,600. In case you forgot, you just use 60 minutes. Convert that into seconds, so 1 minute equals 60 seconds. The minutes cancel, and I'm left with 60 times 60 is 3,600 seconds. And so that's my period. My period is 3,600 seconds. And then just plug in the rest, and the calculator tells you the right answer. I told you that this equation was at the top, but it's kind of hidden. Because if you look at that part of the equation, this part is acceleration. The equation right next to it says that mass times the centripetal acceleration is the tangential, or is the centripetal force. So if you get rid of the mass, you're left with the centripetal acceleration. So it's there, but it's not there. You're going to need to use that on these problems. Remember that the period is always the inverse of the frequency, and vice versa. Right? I've had questions all day today on how do we know which one's period and which one's frequency in the problems. The way that you can tell in a word problem whether it's the frequency or the period that they're giving you is what are they actually talking about. If they're talking about how long it takes to do something, then it's the period. Right? But if they're talking about how many times you do something in a certain length of time, that's your frequency. And after a while, you'll get better at finding out which one is which. All right? But you really just have to ask yourself, what are they telling me? Are they telling me about the time, or are they telling me about how many things happen in a certain amount of time? Questions? All right. So work together. You have 10 questions, but there's a couple of parts to each one of the questions. So you have plenty to do. If you get stuck, by all means, you can come up and ask me. But I would prefer that when you go home tonight, if you get stuck, write down why you're stuck, and then tomorrow we'll go over it. Questions? Great. Cool. Get started.